So in this video we're going to look at simplifying or breaking down a radical. So we all probably by now know if we do something like the square root of 49, the square root of 49 is 7. So that makes 49 a perfect square. So basically any number you can do the square root of and get a whole number out of, that's a perfect square. Alright, so now we're going to focus on examples where you don't have a perfect square. So once again, like if we do the square root of 25, square root of 25 is just 5. Okay, we essentially say like what two numbers, if we do the square root of 25, what number squared is equal to 25, and that would be 5. Alright, so the examples we're going to look at and focus on are going to look like this. Let's say I have the square root of 20. Alright, now the issue with this is if I try to think of what number squared is equal to 20, I have no idea what that number would be. And it's for sure not a whole number. Okay, we can look at that by saying, okay, the square root of 16, that gives me 4. The square root of 25 gives me 5. So I know the square root of 20 has to be somewhere in between 4 and 5, but once again, it's not a whole number. So here's what we can do. If you have a radical and you have a number that's a non-perfect square, like the number 20, what you can do is break your radical down into two numbers that are being multiplied together, but they're still under a radical. And what we want to look for is we want to look for what's the biggest perfect square. So biggest perfect square, I'll just say PS, that divides 20. So the factors of 20 are like 1 and 20, 2 and 5, 4 and 5. And if we pay attention to those factors, 20 can be divided by 4. And 4 is a perfect square. The square root of 4 would be 2. Now, the issue with that is that we have to account for breaking this down into 4 and 5, basically. So we leave one of these radicals the square root of 4. We're going to leave the other with whatever's left over, so that's the square root of 5. Now, we can do the square root of 4, so 2 comes out of the radical, but the issue is this square root 5, I can't really do anything else to that. There's not a perfect square that divides 5 other than 1, and 1's not going to do me any good. So what I can do is I can just keep this radical 5 in the radical, and I can rewrite radical 5 with a coefficient 2, and that would actually be my answer. So let's look at another one, because after you get the hang of this, it starts to get a little bit easier. Let's say we want to do, let's say the square root of, let's just say 40. All right. Actually, let's change it up a little bit. Let's find one. Let's do the square root of 72. That way we don't do the same numbers. All right. So if I want to do the square root of 72, once again, I know that I could do the square root of 64, that's 8. I could do the square root of 81, that's 9. So the square root of 72 has to fall somewhere in between 8 and 9, but I can't just do this square root of 72 and get a whole number out. So that means 72 is not a perfect square. But what I could try to do is break down 72 and see if there is a perfect square that divides 72, and I want the biggest perfect square. And this actually would be 36, because 36 times 2 is 72. So what I can do is break these two radicals apart, and then I can do the square root of 36, which is 6, and then I can leave this radical 2 inside of the radical, and that would be my answer. All right, we can even do a bigger one, like we could go all the way up to, let's say we wanted to do the square root of 245. All right, now if we have a calculator, we could just try to put this in our calculator, but it's going to give us a decimal. So then we're going to be asked, okay, let's break this down. And so what I'm looking for, once again, I'm looking for a perfect square that divides 245. And that perfect square would actually be 49, because 49 times 5 is 245. So then I could do the square root of 49, which is 7. I can keep that on the outside, and then the square root of 5 is just going to be left on the inside. All right, now here's how you know you've picked the biggest perfect square. I know I've picked the biggest perfect square here because I can't break down the square root of 5 any further. So that's something you have to check for when you're doing this, just to double check and make sure that you have picked the biggest perfect square. Let's do another one. We're going to do this example twice, but let's start with the square root of 45. All right, so now, once again, I know I can't do the square root of 45 because 45 is not a perfect square. So let's try to break this down. So we want two square roots that are multiplied, but we want to break 45 down, and what's the biggest number that's a perfect square that divides 45? Well, that would be 9. 9 times 5 would give me 45, and then I can do the square root of 9, which is 3, and then I would leave 5 inside of my radical. Once again, you know you've picked the biggest perfect square when this square root that you're leaving in can't be broken down any further. Now, let me back up for a second, and let's say we want to do, let's say I have 9 times, actually we can use 9. Let's say I have 9 radical 45. Well, you'll see this case often where there's a number already on the outside of your radical. Here's what happens. When we break this radical down like we just did, and we bring this 3 to the outside, anything that's already on the outside gets multiplied by any new number that gets brought to the outside. So, in this case, we just did this problem with 3 radical 5, but now if we add in this 9 on the outside, the 9 and 3 are just going to get multiplied, and it would give me 27 radical 5. Let's look at another example of that. Let's say we'll go back and use our example 20. Let's say we had 3 square root 20. All right? And actually, let's do this. Let's change it a little bit. Let's do one we haven't seen. Let's do 3 square root 48. All right, so once again, this 3 that's on the outside, if anything joins it on the outside, it's going to get multiplied. But first, let's see if we can do the square root of 48. 48 is not a perfect square, so we know we have to break down this radical. And a lot of people would end up doing this. They would say square root of 6, square root of 8, just because those are the two biggest factors or quickest factors that come to your head. But here's the issue. Can you do the square root of 6 and get a whole number out? No. Can you do the square root of 8 and get a whole number out? No. So this is why you have to be careful of what factors you pick. You want to make sure you choose two factors, well, one factor, that's the biggest perfect square inside of 48. And that would be 16, I believe. And I believe 16 times 3 would be 48. Let me double check. Yeah. All right. So now this 3 that's on the outside is just going to stay on the outside. So now we can break down the square root of 16, which would give me 4. But then the square root of 3 can't be broken down any further. That's how I know that 16 is actually the biggest perfect square that divides 48. So I just bring down the square root of 3. But then this 3 that was already on the outside just gets multiplied by 4. So my final answer would be 12 square root 3. So once again, when you're breaking down a radical, really the game you're playing is, you're playing the game of what's the biggest perfect square that divides my number. Now once again, if you already get, like let's say I gave you the square root of 81. If you already are doing the square root of a perfect square, you don't have to play that game. You can just say the square root of 81 is 9. But if you're trying to break down the radical and it's not a perfect square, then you're going to have to find the biggest perfect square that divides 48 and use that to start breaking down your radical.